Okay, looks like this one is a simple one. You just need to differentiate that's all. Right? Your displacement is given you. You just differentiate it. Okay, differentiate it 0.04 and differentiate your sine become cos. Differentiate 16, you get 16. Or you can use that formula. V naught is A times omega. Either one, you don't want to differentiate. Use this formula and put in your value. Same thing. 0.64B 18. In which group below do the three quantities remain constant when a particle moves in simple harmonic motion? Remain constant. You want quantity that remain constant when the particle moves with simple harmonic motion. Acceleration changes with displacement. Force change because acceleration change. Total energy is constant. Right? So force, total energy is constant. Then amplitude is constant. Force changes. Right? Total energy is constant. Amplitude is constant. Angular frequency is constant. So answer is your C. Acceleration varies with displacement. Same as force because force is just mass times acceleration. Okay, angular velocity is constant. What is the frequency of a simple harmonic motion if the acceleration A is related to the displacement by the equation x by the equation A equals to minus kx. Okay, number 19, what's the answer?
I thought 15 questions only, Jer.
Say again.
I thought 15 questions only.
Yeah, we will do a few more. After that, we will go to structure question. Number 19. Donkey. Right? Compared to the standard equation definition. Right? Omega square is K. So omega is 2 pi F. Right? Frequency. So omega square is 4 pi square F square equal to K. That from there. And donkey, okay. Right, let's try the last one. Then we go to structure question. This one. A particle is in simple harmonic motion along the x-axis with amplitude A and period T. What is the time taken for the particle to move from position minus 0.5 to plus 5 by amplitude? Okay. How to solve? What's the answer? Yep. Why so long? Right? Can use the equation from 0 to 5. I can calculate the time. Okay, A and A can cancel off 0.5. 0.5 is 5 or 6. Right? 30 degrees. 30 degrees is 180 divided by is pi over 6. So we get T over 12. Then from 0 to 0.5, 0 to 0.5, the time taken is it's just double, right? Double the time, right? Because it's from 0 to 0.5 is the time, and then from 0.5 to 0 is the same time. Then from 0 to 0.5 is also same time. So with times 2 is from 0.5 to minus 0.5, just times 2. Okay, can or not? Can or not? Any problem? What's the problem? What's the problem? No problem. Can understand.
So far, yeah.
Okay, let's go to a structure question then. The structure question. A particle is in simple harmonic motion when its displacement from the equivalent position is 5 cm, its acceleration is 45. Calculate the angular frequency. Okay, what formula should I use? Yep, what formula to use? Any idea? Too tired to think. Use the definition. A is
3 rad.
equal to minus omega square x. Then you can put in your formula to find your omega. Omega is just, don't worry about negative sign. Negative is just the direction, A over X. And put in your value of A and your value of X. Get 3. Then period is just T over 2 pi omega. Right? Omega, we will calculate. Put in your value and calculate. Frequency of a simple amount motion, frequency is 1 over T. Okay. Anything not clear? If not, let's go to number 2. Two particles P and Q are in simple harmonic motion with the same angular frequency and have the same amplitude. At time t equals 0, P is at the equilibrium position, and the displacement of Q is from the equilibrium position is plus 0.85a. Deduce the expression for the displacement x in terms of time t for P and Q. Okay, what's the equation for P? Any idea? Yep. Any idea? It's a bit challenging, this one. Apply your knowledge. Right, write your equation. That's for your P. There's a general equation. You start from 0, this one. Then your Q. Q is slightly earlier. Right? This one is positive. So it's slightly earlier. That's why we put a plus there. Plus 5. Then put in your value. At time t equals to 0. That's equals 0. Right? Is 0.85. That one there. A sine 5. Then calculate your phi. On the same axis, sketch the graph. Yeah, sketch the graph. Right. That's your graph for P. And that's your graph for Q. Right. That distance there should be this value, or that value here should be 0.85, that one. Right? The maximum should be A. You can write your A there. When the distance of the particle P is at A, where is particle Q? How are we going to do that? Yep. Yep. How to do that? Any idea? Right? Where is at maximum? This one must be for P. This one must be A. So A and A cancel. This becomes 1. Right? 1 is sine 90 or pi over 2. So P is at A. We got omega T is pi over 2. And your Q is your, right? Q, that's your equation. There's your omega T. Omega T is just that. And plus 1.02. Put your equation. Calculate out. Okay, can or not, can or not, can or not. Any comment? Why is not clear? I just go with P first. Right. Put X equals to A. So A and A cancel, this becomes 1. Right? 1 means sine 9 pi over 2. So pi over 2, 90 degrees equals to omega T. Right? Not interested in the value, so now to calculate. I got omega T there. That's my pi over 2. Then I calculate out. Get the value. Okay. Okay, let's go to number 3. A mass hanging from one end of a vertical spring performs vertical simple harmonic motion of amplitude 2 cm. In 4 seconds, there are 3 complete oscillations. What is the acceleration of the mass at the equilibrium position? Straight away, you should be able to know what is the value. What's the answer? For A. Yep. Srini, what is the answer for A? Yep.
0.
0. Right? All you need to really do is remember your remember your graph there. Right? Or go to the formula. There's a formula. This formula. Right? X equals to 0. A is also 0. Either one, either way. Either memorize the graph. Okay. You should be able to say, write down the amplitude. And then your total 3 complete oscillations in 4 seconds. So in 1 second, how many oscillations? 3 divided by 4. Should be able to get the frequency. Then omega is 2 pi f. Calculate your omega from there. So A is just A equals to minus omega square x. So x equals to 0, A is 0. And B, the position of the maximum displacement. Use the equation. What's the acceleration of the mass at position of maximum displacement. Okay, use that equation, same equation there. Omega square, we have already calculated. Omega, we have already calculated. Square that. X is right. The maximum amplitude is 2. If you use cm, you get in cm. So it's 44.4 cm second minus 2. Okay. Stop me if you need further explanation. If not, let's carry on. One end of a tuning fork vibrates in simple harmonic motion of frequency 1000 Hz and amplitude 0.4 millimeter. Find the maximum acceleration and the maximum speed. Okay, from the information there, you should be able to say, okay, that's the amplitude. And then frequency, you can calculate your omega is 2 pi times 1000, 2 pi f. Calculate that out. Maximum acceleration, A is just your omega square x. Right? Omega is just square that one there. Don't worry about negative sign there. Square the omega x. X is changed to meter. Then you get meter per second square. That's your A. And maximum velocity or maximum speed. A times omega. That's your A. That's your omega. And we convert it to meter. Calculate out. Acceleration and speed when the displacement is 0.2 millimeter. Same. Just repeat the calculation for this one. Right? A is easier. Omega is that omega square. Change to meter. Then you get your answer is meter. So how to calculate your V, your speed. Any idea?
No, sir.
Right? Use this formula. Right? As I said, you want the magnitude only, the speed only, so don't worry about plus minus. That's your omega. A is 0.4. Right? X is 0.2. I'll take the 10 to the power minus 3 out. Rather than square, I take it out easier. Then calculate out. Okay, anything not clear? Then deduce the expression for the displacement x in terms of time t. Okay, what have we calculated? Calculated all that. Your x equals to a sine omega t. That's your a. That's your omega right down there. Okay. This is a sine graph because you're assuming that at time t equals 0, the end is at the equivalent position. Okay, any comment? Let's go to number 5 then. A body is on horizontal platform which perform vertical simple harmonic motion of amplitude 10 cm, that's amplitude. Above a certain frequency, the reaction of the platform on the body becomes 0 at a certain point in motion. What is the value of the frequency and at which point of the motion does the reaction becomes 0? Okay, it is going to go up and down. So you increase the frequency, the acceleration is going to be increased further and further. Right? So if that's the rest position, it is at the bottom there. At the bottom there, the mass is pressing down on the platform. So the acceleration is too large. Right? Gravity cannot catch up with the acceleration, so there's a loss of contact. Or same at the top there, maximum amplitude, where the acceleration is large. And coming down, it accelerates faster, so that it loses contact, so the reaction is 0. Right? So in this case, where the acceleration is 0, when the pendulum vibrates with acceleration due to gravity, the phantom lose contact with the body. That's where the reaction is 0. Right? So go to the formula, put A equals to G. Right? Don't worry about negative sign there, because you're only interested in the positive value, frequency. So A and X, A is 9.81, suction due to gravity, X is 0.1, so you get 9.90. Okay, then calculate your frequency, omega of 2 pi, put your omega inside there, omega value, 2 pi, calculate out. Okay, any comment? If not, let's go to one essay question. The rest you can try yourself and ask me if you cannot do it tomorrow. No question, let's go to essay question. Let's try the number 1. Okay, how to define? Yep, define for me. Can or Srini? Check your book. Make sure you come for class. Don't sleep in class. Right? Make sure you sleep first before you come for class. If not, it's a waste of your parents' money. You come to class and you sleep in class. You're wasting your money. Right? It's just memory work. 2 mark. In simple harmonic motion, or S.H.M, the acceleration is proportional to displacement and is always directed to rest position. That's all. A mass M hangs vertically on a spring with spring constant K as shown in the diagram below. The extension E is 2 cm and the mass M is pulled down a small displacement less than E and released to oscillate around the equilibrium position. At time t, the displacement of the mass from the equilibrium position is x. Show that the mass oscillates as a simple harmonic motion. Okay, taking downwards as positive. Right? For equilibrium position, your mg equals to ke. Then you force upwards when the mass is when you pull it down by displacement x. There's a resultant force upwards. Right? So the new force is a k into e plus x. Previously it's only ke. Now you add another distance or displacement x, so e plus x. So resultant force you subtract. Right? Outward force minus ke. That's all. And since it's a resultant force, using Newton's second law, ma, right? I put a negative sign because the force is outwards, the displacement is downwards. So ke cancel off. You got your answer. So A is proportional to X. That's all we need to do. Determine the period. Right? So we have shown that A is proportional to X and is always opposite to displacement. Negative sign there. Okay with that? Okay, no answer means you're all right. Let's carry on. Right? Determine the period. Right? That's what we have obtained. mg equals to ke. So mk equals to e over g. So that is what we have derived previously. Then compare with the definition. Right? That's omega square. So omega square equals to km. So t is 2 pi over omega. And omega is that's omega square. That's what we get. Right? If you want in terms of e over g, then e over g. Since they didn't give you your k, if you ask, they give you your m and k, you can write your answer as that. Okay, or the answer is that, whichever the question is not clear, which one they want. Okay with that? Any comment? Right? Determine the period. Since they are given you E, you have to convert to E, E over G from this equation. They want you to calculate the answer. So your E is that one, change to meter. G is 9.81, calculate out. A mass 5 gram performs simple harmonic motion represented by the equation, where Y is a displacement in centimeter and X is the time in second. Determine the maximum kinetic energy of the system. Okay, how to do that? How to do that? Any idea? Yeah, Srini, how to calculate that? Yep. How to calculate? I think next time we'll ask you to turn on your video already. Then I can see what you are doing. How to calculate the maximum kinetic energy of the motion?
Y equals to A sine omega t. That means A is 2 centimeter. The omega is 4.0 rad. And then kinetic energy 1 over 2 m omega square A square amplitude square.
Say again.
No, amplitude is 2 cm. Omega is 4 rad.
Amplitude is 2 cm. Omega is 4, correct?
Maximum kinetic energy means you can use 1 over 2 m omega square A square. Because V square is equals to omega square amplitude square.
Okay, there's the amplitude for velocity. Right? Maximum velocity. 4 times your, that one change to meter. That's your maximum velocity. The kinetic energy is mv square. That's all. Maximum, easy to calculate. Put in your value and calculate out. Potential energy. Right? Use the potential energy formula. Oh, this one you have to calculate the displacement. So you have to put your time inside the equation. So it's 1.68 cm. And use the potential energy formula. That's a potential energy formula. Put this one, convert it to meter. Right. Mass is change it to kilogram. Omega square is 4 square. Y, that's your Y, change it to meter, square that. Okay. Any comment? Okay, I will stop here. Yeah, too tired. Make sure next time you come for class, you better take a short nap first before you come. I'll stop here. Anything you want to ask?
No.
Okay, you stop here. You want to go, can go. Got question, can ask. If not, I will stop here.
No, that's it, teacher. Thank you.
So I have sent you the worksheet for wave in motion. Right? You can try to fill it up as I teach you.
Teacher, what chapter are we in right now?
We are going to chapter 20 tomorrow. We are doing chapter 19.
Tomorrow.
Today we complete chapter 19 for you.
Oh.
So
that means my school going very fast lah.
Too fast.
Yeah,
right?
Now only third week already, so fast already.
Yeah, third part. You got until February or March there. I don't want to go too fast. I go too fast, you got lost, you never do your homework, then you will lose your interest in physics. That's the reason why I go so slow. Make sure you do your homework. You don't do your homework, you do it in class. Right? Make sure you do your homework. That's how you're going to learn. No point in going too fast and then you lost everything.
Okay. Okay, Chef.
Okay,
Thank
bye-bye.
you. Have a good day.
Have a good day too.
Thank you. Bye-bye. Till
Bye-bye.